Hello there, and welcome back to another day where I have some free time. And in this day's video of unstd-c, we'll be trying to pass the usual arguments to main, as right now we are passing no arguments to it via inline assembly. So let us get started. Here in the C runtime. Well, we know that in the syscalls, the function arguments are first in RDI, it's passed in RDI, then RSI, then RDX. Then there's R10, then R8, and R9, those six. But for user functions, well, it's almost the same, but the first three are the same, so RDX. But the next one is, I think, RCX. But let's just consult the system VABI over here. For, I think it's in program loading. No, low-level system information and function calling system, a sequence. So parameter passing, maybe we're getting farther from truth. So what's the usual one? Or maybe it can be found in the Linux conventions. So user level applications. So it's RDI, RSI, RDX, RCX, R8, and R9. So it differs in R10 over here. So you can try this out. Oops, I deleted that one. So where can we find the argument count or args? Well, we can find that in RSP, and the argument pointers seemingly is 8 bits above RSP. So maybe we can just move that. So RSP to RDI, and then 8 bits above. Well, let me check the object dump just to see, well, how this might work. So let's try that on build. So I see that over here, maybe this is the way we do it. Move 8 bits above RSP and then put that in RDI. So we'll copy that. But, well, we can try it now by rerunning build. And, well, let's run that with GDB just in case. But of course, we have to make main accept arguments. And hope that it will not get optimized out by the compiler. So maybe we can just return argc so that it will not optimize it away. Then run our hello via GDB and see what would happen. So break at start. And let's run it. Step over. Wait a minute. Well, that's unexpected. Let's just check the object dump of that hello. Since there's no line information. Or maybe I forgot something. Yes, I am forgetting something. It is to add debug information over here. So in the compile flags over here, I'll add -g, and over here as well in the C runtime. So I have to rebuild this along with hello, and then we can run it again by gdb. So break start, then run. So step over, argc is 1, surprisingly. And let's try printing argv. Wait, no, the first one from argv. Okay, that's bad. So maybe what we passed in is not the actual double pointer, but just a normal character pointer. I guess that's wrong as well. So I wonder what part we did wrong. So argc is surprisingly right, but maybe we're missing something else. So rsv is the stack pointer that holds the address. So we actually have to dereference this as well. Maybe that's done with the parentheses. And I'll just add 0 over here just to make it line up. But I wonder what else is wrong. Maybe, well, as we've seen earlier, it was just a character pointer, not a double one. So we somehow have to get the address of this. And I think there's something like load effective address in x86-64. Oh, it's Leah. So let's try this again. Well, of course, recompile hello as well. Break at start, run it, and then step. Oh boy, that's quite the wrong argument count over there. So we have to check the object dump of this. And it's doing something else. It's moving the base stack pointer somewhere. So, huh, maybe we have to shift this by another byte. So this will now be 16. Since, well, it's doing something else over here. So let's recompile this. Run gdb. Break at, well, just break at main. Then run it. So it's the wrong argument count, but let's print out argv. Well, the first one anyways. It's null. And now we're poking into memory that we shouldn't have access to. So, oops. This is wrong then. since, well, we're copying the same thing into RDI. That should be RSI. Why did I just copy and paste that? And did not even check. So break at main, then run. Now we have the correct arg count, and let's see argv. So we actually did have to move it by a byte. So we now have argument, the argument count and argument vector passed in main. So let's make it GDB. We'll pass it something else. So dash V, dash A, and dash B. Break at main, then run it. Then print out argv 0, 1, 2, and 3, and 4 being null. Very nice. So we can quit that now. And we're now passing the arguments to main over here. So that's that one done. And so that we do not have to rely on GDB anymore for printing our variables, well, let's have a generic function that will do syscalls for us, since we will now need the help of the kernel to do IO stuff. So that will be our goal for the next video. So make a generic syscall function. So thank you for sticking with me this far, and may I see you on the next one.